Okay, in this exercise you will learn how to use the calculator to solve binomial probability problems. In this exercise I've covered everything you need to know about binomial probabilities. Suppose that 70% of adults with allergies report symptomatic relief with a specific medication. If the medication is given to 10 new patients with allergies, what is the probability that it is effective in exactly 7? Before you do any binomial problem, first of all you have to state the value of P, which is a probability of success. In this case it is 70%. Usually the percentage is a probability of success. And then the number of trials, which is patients here, so N is 10. So I've written this down. In order to find the probability of exactly x equals 7, there is a function in the calculator called Binomial Pdf. I'm going to show you how to use it. So you just go to second, variables, you scroll down to Binomial Pdf, it's right there, enter. Number of trials is 10, it's already there, I put it there already just to save time. P is 0.7, the x value is 7, scroll down and then paste. If you have an older operating system, it's gonna show you Binomial Pdf and open parentheses, so you would enter 10, 0.7, comma 7, and then press enter here, and here is the answer, 0.2668. The next question, what is the probability that it is effective in at most 5? At most 5, guys, means x less than or equal to 5, so we need to find the probability of x less than or equal to 5. X less than or equal to 5 means it could be 5, it could be 4, it could be 3, it could be 2, it could be 1, it could be 0. You could go back to the formula that we use in part A and do it for 5, for 4, for 3, for 2, for 1, for 0, and add them up. But the calculator does a better job. There is a function called Binomcdf, which does only x less than or equal to a number. So remember that, less than or equal to a number. So let me show you this formula, variables. I'm gonna scroll down to this formula. Okay, it's CDF. It's gonna ask me for the number of trials, which is always 10, for the probability of success, which is always 0.7, and the x value here is 5, and then paste. And Binomcdf, I did paste it in here, and then we're just gonna hit enter and get the answer, which is 0.1503 for 4 decimal places. Part C, what is the probability that it is effective in more than 5 patients? As I told you, the calculator has only 2 built-in functions for binomial probability, one for exactly equal to and the other one for less than or equal to. There are no other functions, but we're gonna try to rewrite the problem in a way that we can make use of those functions. So x greater than 5, guys, means 6 or 7 or 8 or 9 or 10. That's what we want. But so 6, 7, 8, 9, and 10. What are the numbers that we did not cover? 5, 4, 3, 2, 1, 0. The calculator can find for us probability of x. We can find the probability of x is less than or equal to 5 using the calculator. We don't need this one. We want greater than 5. But the calculator can find the probability of x is less than or equal to 5. And since the sum of probabilities equals to 1, so once we find the probability of x less than or equal to 5, we can subtract it from 1 to get the answer to our question. Okay, probability of x less than or equal to 5, it's going to be what? Binomcdf, and then we're going to put the 10, we're going to put the comma, 0.7, and we're going to put what? The 5. Have we done that already? Yes, we did that in part B, and I got the answer already, which is 0.1503. So how do we find probability of x greater than 5? We just do 1 minus, so it's going to be a 1 minus 0.1503, and the answer will be 0.849 Okay, so if you want a formula, every time I ask you to find a probability of x greater than a number, let's say n, I'm not gonna call it n because I'm using n there for number of trial a, you just do this, you do 1 minus probability of x is less than or equal to a. And less than or equal to a, you can use the calculator, the binomial CDF. What's the probability that is effective in less than 7 patients? Okay, what does less than 7? Less than 7 means a 6, a 5, a 4, a 3, a 2, a 1, a 0. So I think you should agree with me that less than 7 means less than or equal to 6, and that's what I put here. Less than or equal to 6, guys, you can use the Binomcdf on that one. Let me show you how I can recall this formula without having to do it again. So if you press second and enter, you will get it back. And just I'm gonna move the cursor back to 5 and change it to 6 here. And press enter, and here's the answer. The answer is 0.3504. So I'm gonna give you a formula here. If you're asked to do probability of x less than a number, let's say a, you just do probability of x less than or equal to what? 7 went down to 6. So for our case, a will go down to what? To a minus 1. Why we keep going to less than or equal to? Because the calculator has the Binomcdf, which means less than or equal to. Okay, so you can do this. E. What's the probability that it's effective in at least 4 of them? Okay, at least 4 means what? 4 or 5 or 6 or 7 or 8 or 9 or 10. That's what we want. What is it that we excluded? We excluded the 3, the 2, the 1, the 0. What I can do here, I can use the calculator to find the probability of the ones that we excluded. X less than or equal to what? To 3. And after that I do 1 minus. So probability of x less than or equal to 3, I'm gonna do a second and enter, guys, and then I'm gonna scroll down to here 3, press enter, and I got the answer, which is 0.0105. if we will be 0.6 if we do 4 digits. Alright, so our answer will be probability of x greater than or equal to 4 will be 1 minus probability of x less than or equal to 3, which is 1 minus 0.0106, and then equal. You can just use the calculator also to compute the final answer, guys, no problem. And here you go, that's the answer. 0.9894. Last question, what is the mean and the standard deviation of binomial distribution? There is a formula of mean, it's n times p. N is 10 times p, which is 0.7, and the answer will be just 7. What is the standard deviation? There is a formula, it's square root of npq, which I will provide on the test. You don't have to memorize this one. Let's do a square root of npq in here. So I'm gonna go to second and square root, and that would be 10 times p, which is 0.7. Now what is q? Q is the probability of failure. If the probability of success is 0.7, then the probability of failure is 0.3, 1 minus 0.7. So, and then press enter, and my answer is, let's say, to 3 digits, 1.449, and here note that q is 1 minus p. I hope that this exercise helps, but it does cover everything you need to know about binomial distributions.